What up? It's your boy C Rizzy coming back at you with Unit 9, Lesson 6, Dilations. Our essential question, how can you change a figure's size without changing its shape? And our objective is to understand dilation images of figures. So you can use a scale factor, which we learned about last section, to make a larger or smaller copy of a figure, but that is also similar to the original figure. So here is the properties and characteristics of dilations. So a dilation always has a center of dilation, which we represent with the letter C, and a scale factor n, where n is greater than 0, can be written as dilation given your scale factor and your center of dilation. A dilation is a transformation with the following properties. So if we look at just the picture, we can kind of see the properties, and it's a little bit easier to understand. So the distance from C to P, okay, is some value. We'll call it x, and the distance from C prime to P prime is n, which is your scale factor, times whatever that distance from C to P is. Right. So in this picture, we can see we went from our pre-image in black to our image in blue. This scale factor n must have been greater than 1 because this was an enlargement. We'll get to that in a little bit. The other thing you want to take note on is how from P to P prime, if you were to draw a straight line through P to P prime, you end up at the center of dilation. Q through Q prime, you draw a straight line, you end up at the center of dilation. R to R prime, you end up at the center of dilation. So if you were to draw straight lines through your points, where your three lines meet, or where they intersect, is your center of dilation. A dilation is an enlargement if the scale factor n is greater than 1, and a dilation is a reduction if your scale factor is in between 0 and 1. So it's an enlargement if you're working with values like 2, 2.5, 3, etc. And it's a reduction if you're working with values like 1/2, 1/3, 2/3, 5/7. Okay, those are fractions less than 1. Okay, let's look at our first picture. We can see from the black triangle XRT to our blue triangle X prime, R prime, T prime, we want to figure out whether this is a reduction or an enlargement and what is our scale factor. So first things first, from black to blue, our triangle is clearly getting larger, so the reduction is out. And the next question is, what is our scale factor? So seeing your values of 4 and 8, a lot will immediately assume, oh, it's got to be 2 because 4 times 2 is 8. But you have to pay a little bit closer attention to the fact that 8 doesn't represent the distance from x prime to t prime. 8 represents the distance from t to t prime. So this whole distance isn't 8, but this whole distance is 12. So what we're looking at is what number times 4 gets me 12. That's what the scale factor is. So our answer is B. And on this slide, it just gives us a little bit more work and a little bit more detail on why the answer is B. That's not important. Okay, what are the coordinates of the vertices of this triangle after a dilation of a scale factor of 2? Now, if they do not give you the center of dilation here, they give us a scale factor of 2, then our center of dilation is the origin. Okay, the origin right here. So when the center of dilation is the origin, this problem becomes much simpler. Z is at -2, 1. G is at 0, -2. And P is at -2, +2, -1. So when your center of dilation is at the origin, all you have to do is take each one of your coordinate points and multiply by 2. Because that was our scale factor. So Z prime is going to be at -2 times 2, which is -4. 1 times 2, which is 2. G prime is going to be at 0 times 2, which is 0, and negative 2 times 2, which is negative 4. P prime is going to be at 2 times 2, which is 4. Negative 1 times 2 is negative 2. So again, there's all the work done out for you again. And here is our new triangle. Again, notice if you connect or draw the lines from your pre-image points and your image points, all of them should go through the center of dilation. And they do. They all intersect at the origin. Okay, one more problem. What if I took that same triangle and I was dilating it by a half? So 1/2 means that this must be a reduction. So the triangle is getting smaller. So let's just recall where our points were. Z was at negative 2, 1. G was at 0, negative 2. P was at positive 2, negative 1. So now I'm multiplying everything by a half. And remember, multiplying by a half is the same thing as dividing by 2. So Z prime, negative 2 times a half, or negative 2 divided by 2 is negative 1. 1 times a half is a half. 0 times a half is 0. Negative 2 times a half, or negative 2 divided by 2 is negative 1. 2 times 1/2, or 2 divided by 2, is 1. Negative 1 times a half, or divided by 2, is negative 1/2. So looking at our coordinates, our answer must be, I believe it's C. All right, that's all from me.